See this problem. A series resonant circuit contains L1, R1 and C1. The resonant frequency is F. Another series resonant circuit contains L2, R2 and C2. The resonant frequency is also F. If these two circuits are connected in series, calculate the resonant frequency. So our motto is, there are two LCR circuits. So not in exactly the order, but all are same. There is L1, C1, R1, L2, C2, R2. So each individual circuit have their own frequency F. So if our motto is to find if these two circuits got connected in series with an AC source, we need to find out the resonating frequency, final resonating frequency Fs, because for the series connection only we are finding the frequency, so I am naming it as Fs. So final resonant frequency we need to find out. That is our motto. Now I am going to investigate. So there are all are not numericals, all are expressions only. So just I am mentioning the expressions L1, C1 and R1 with the resonating frequency F, L2, C2, R2 with resonating frequency F. So those are the given quantities. With this I am writing with the resonating condition. So resonating condition in the sense the frequency of resonant frequency of an LCR circuit will be written as F is equal to 1 by root L1 and C1, and for the second one is also 1 by root L2 C2. So assume those are 1 and 2 equations. So we need to find out the resonant frequency when those two are connected in series. So I am going to resolve everything. So while resolving, so I want to write for example, while resolving I want to explain these circuits. If we connected in series, so look at this, R1 and R2 are in series. R1 and R2 are in series. So if two resistors are in series, what is the resistance of those circuit? That Rs is equal to R1 plus R2. Similarly CS is equal to C1 C2 by C1 plus C2. We already know when two capacitors are connected in series, the effective capacitance 1 by CS is equal to 1 by C1 plus 1 by C2. So after simplification I have written this. And now for inductance also written as Ls is equal to L1 plus L2. For a series combination, the inductance is also going to be added because you are just combining the coils. So adding the coils leads to adding the inductance. Now from those two equations, like from the first two 1 and 2 equations, it is clear that L1 C1 is equal to L2 C2. So we got 4 expressions, like after combination, what is the resistance and what is the conductance and what is the inductance, and what is the relation that we got, final relation that we got with the conditions. And now I am writing the expression for the resonant frequency of the combined equation. So resonant frequency Fs is equal to 1 by root Ls and Cs. So according to the resonant frequency formula, I am writing this Fs is equal to 1 by root Ls and Cs. Now what is Ls? So 1 by root LS is L1 plus L2 and CS is C1 C2 by C1 plus C2, that is equal to 1 by root, I am just simplifying it, I am multiplying this to C1 and C2, so L1 C1 C2 plus L1 C1 C2, so L2 C1 C2 divided by C1 plus C2, that is equal to 1 by root of, look at this, L1 C1 is there here and L2 C2 is also there. So now I am replacing any one of this with the other one, like with the given condition I am writing this. So instead of L1 C1 I am writing L2 C2, C2 is there already, plus L2 C2 C1, I am just reshuffling this expression, divided by C1 plus C2, that is equal to 1 by root of, so L2 C2 is there and here also L2 C2 is there, just I am taking out as common L2 C2 into C2 plus C1 is the remaining expression on the numerator, and denominator C1 plus C2, these two gets cancelled. So what is the remaining component? 1 by root L2 C2. I think we have seen this expression previously. What is it? It is f itself. Like, look at this, f is equal, for the second thing we got 1 by root L2 C2 is represented as f. So now the resonant frequency is equal to f itself. So if you substitute here, look at this, in this expression you have substituted L2 C2 instead of L1 C1. If you go with this, then that means if you substitute L1 C1 instead of L2 C2 here, you will get expression here you will get expression in terms of 1 by L1 and C1, which is also same as f. So the final resonant frequency, even after you combined in a series, it is also f.